all of you know what is innovation. It's basically going from idea to the whole process of developing the idea, verifying it, implementing it, and then going to the market. Basically, doing value addition. So, most important thing is when we do research, which is most important for innovation, which is the basic input. It is important that we take it to a level where we are in a position to do a certain amount of value addition, and that value addition will lead to economic growth. So how do we do this innovation? There are strategies for doing this. Create competitive communities by promoting regional innovation. We need entrepreneurs who should be facilitated to collaborate with local researchers, educators, and industry partners to foster specialized knowledge, technical expertise, and cutting-edge products, and a strong academia, national labs. I am specifically talking about national labs because of one fact which I mentioned yesterday also. The fact is that in industry today, there is a growing R&D which was not there earlier. But since that is still in the nascent stage, national laboratories, which are the one which do translational research and also convert ideas into products, they should become the nucleus for integrating the universities and the industry together in the form of facilitation. And certainly it will be through the policy framework, incentives, public funding, and outcome-based performance monitoring, because unless we monitor the outcomes, we can't get what we need through this collaboration. And that's why, what are the challenges? And this is what everybody to understand, because there are two different communities which are looking at different things in different point of time. For industry, the focus is on realizing commercial return and creating value for the stakeholders. Whereas for academia, it is a tradition that has been to focus on basic research and educating the citizens of the future with less regard for the commercial return. Industry is driven by obtaining protection for innovation to develop new products and new revenue, whereas academia is typically concerned with publishing research results to enhance knowledge and reputations. Successful industry collaboration is built on mutual benefit. So we have to make this mutually beneficial. For example, for universities, typical incentives for collaboration with the industry include improved access to funding, business insights and practices, and enhancement of reputation. For industry, incentives for collaboration with academia include access to academic expertise, publicly funded resources, latest research insights, and also innovative new methodologies, opportunities to provide training to the potential future employees. And companies may also benefit by sharing the cost of R&D and by potentially influencing the academic research. So what are the primary considerations for this collaboration? Let's look at that. First is the government, which is a major stakeholder in the entire process, how it should facilitate. From the government side, they should actually increase what is called the funding, investment in the directed basic research. This is what we have been talking since yesterday. Increase investment in translational research. And innovation comes from people. That's very important. Because people are the building blocks for doing any innovation. So a student component of the university research particularly should be exploited or harnessed for innovating by setting up research parks, incubation centers, and so on. Another one is commercialization by early stage investment, and that investment should continue till the innovation value of death cycle is overcome. I hope many of you understand what is value of death. You go from concept to making prototypes and then going into the market. There is a big ravine there. We'll discuss that a little more. And today the funding, if you look at today, on the government small business innovation research and small business technology transfer programs are underfunded. That's why a large number of people give me a ring every day today. Sir, we want to do this. Students are talking. We want 5 lakhs rupees to just do certain consumables to be bought or some materials to be bought for verifying our idea. There is no method by which these needs are completely fulfilled. So there is a underfunding as far as this is concerned. Standardized terms in sponsored research and licensing agreement. There are lots of issues which many times actually mar the whole thing of this joint research, because we have not standardized the licensing agreement. For example, we should be in a position to set up an ideal university industry demonstration project. So that will become actually a framework for tomorrow. Recruit top-notch entrepreneurs in industries. That is for the universities. If you are really looking at the university is getting into it in a big way. We should get the entrepreneurs as residence engineers to identify opportunities and introduce valuable application targets. Each EIR should be committed to spinning out some products, some companies. Provide commercialization, postgraduate opportunities. Universities should find ways to retain essential entrepreneurial contributions of graduate students after they complete their degree in order to sustain momentum of the engineering startup. And universities should take engineers from industries on deputation contract to facilitate demand-driven R&D. That will certainly help. Few things about industry: invest in early stage funds. One has to set up fiscally prudent funding models that make smart money available to early stage companies. Advice on industry needs. What industry needs, we have to give them that. Create joint industry consortia among university and industry. Industry should make investment in in-house research. This is very important. Must encourage participation of academicians in industry-owned research and development setup. That means we should also get the professors and the research scientists to come and work in the industry on various programs. Everyone today has seen that innovation is one of the economic currencies for the next century. Sorry. Things that can put the brakes on what is an otherwise good working relationship. Actually, if you look at this relationship, one of the things that generally happens is loss of trust, breaking any part of the equation which has been set up. Unclear or messy IP position. Many people, they get worried, industry particularly, or the researchers, they get worried, what will happen to my IP? Unrealistic valuations. Academics who cannot use an industry project to fund a whole research group. Similarly, industry, just because academics receive public funding doesn't mean that subsidies all of their output. Inability to deliver. This is one of the things. Basically, they get worried. No, R&D labs don't deliver, universities don't deliver. So as a result, the industry doesn't want to come forward. Changing direction of research. There are many times, many programs of this kind have suffered because mid-course you have changed direction. And you have changed direction because you found there is something else better coming in. And as a result, industry is not getting the output. So never do that without an agreement. Straying from publication agreements. Publications are a must, but there should be an agreement. Lack of confidentiality. Many times people fear that confidentiality will not be maintained. Lack of communication, most important. Nearly all problems that can damage a collaboration can be avoided by good and timely communication. Both parties need to understand pressures and driving forces on each other. There are various models. I am going to talk to you only one model which we have experienced while working in defense. I think Satish also may like to mention that. Sorry for maybe it is a repetition at that time, but we can always manage it. Dr. Kalam, I call it Kalam model, directed basic and translational research. His model was identify technical problems in a major mission mode program, which required research, development, and innovation. Search for institutions and academicians having interest, experience of working in that discipline. Hold discussions in formulating problems and research strategy and identify the requirements of funds, human resources, and time schedule. This is the spade work you have to do. Form joint teams of scientists, engineers, academicians, and industry partners with leader and a co-leader from both organizations, and create an inter-institutional management platform to monitor, accord financial sanctions, and suggest mid-course changes. For example, we set up what is called the Joint Technology Advanced Center at the Institute of Science during the IGMDP days, which is even today existing, and 37 projects were done, and output of those projects were used for designing the missiles at that point in time. Share experimental and simulation platforms across organizations without any hurdles, as if you are on a freeway. Hold discussions with mission teams during the R&D phase for suggestions. There is a mission guy who is going to make use of your output. You should hold discussions with them. And then take their suggestions for validation and feedback with reference to the application of the outcome in relevant design and development process. Integrate the results of the R&D in subsystem, system design and development process. And don't stand away that I have given the output, now my job is over. Be part of the mission team for swift integration and carrying out mid-course corrections and resultant iterations if required. This strategy helps develop long-term collegiate relationship among experts and organizations for collaboration. I can tell you the professors who worked on those programs in 1984, 85, 86, 87, even today, they are part of the development programs of DRDO. So that is a kind of, and similarly with the industry, those who participated, today they are still working as partner. And this helps you to take the system into what is called through a technology transfer, because the consortia of the industry was there, academicians were there, and this consortia helped the complete technology transfer going from prototype to mass production and reduce time and cost. This also helped in taking industry from a mere component manufacturer to today design, build and strategic partner today they have become. A large number of industries today are strategic partners in development, and this is how the growth has taken place. I'm just giving you the names of the industries who have been only a component manufacturer once upon a time, and two of our major colleagues are sitting here, Mr. Patil and Mr. Baba Kalyani, who have been part of this journey from growing from a mere component manufacturer today to system designer, and they have become built to specifications. There are various other models, what Dr. Kalam gave was some. Now today we have a model of what is called setting up research parks. Indian Institute of Technology Madras and Indian Institute of Science jointly we have set up research parks for both combustion research as well as for aerospace research. Research park at IIT Madras, research park at IIT Bombay and IIT Madras, DRDO research park at Kharagpur, Jadavpur University and Calcutta and with Samir. Now these are for different disciplines, taking into account that DRDO, industry around that region and the IITs work together for solving problems. The same methodology we are replicating now for the railway research centers at IIT Kharagpur, IIT Kanpur, IIT Delhi and IIT and other places for different domains of railway research program. Other things which have been followed so far are extramural research. Industry research identifies area of R&D for a specific application, and government identifies areas for basic research like nano AI and doing the funding. Academics institutions are funded by sponsored agencies, and so you have industry consultancy. Basically, there are development contracts through which you are in a position to have a very good industry interaction, and those are, it could be built to print. You have given the design, the industry will print, build to specifications. You are given a specification, they will develop the product and manufacture. And the final thing today, what has happened is they will do build to requirement. Today, if I tell L&T, you have to design a launcher for us for a particular missile launch. This is the requirement that it should operate like this, all that. They are in a position today to completely design the system and deliver. So that is a kind of graduation that takes place through this collaboration. Funding is a major issue in all these industry and collaboration. Basic research, I personally believe that should be grants from the government. Applied research, industry association should be there, and industrial firms, applied research specific, they should also come into the picture. But then this is the innovation cycle. The first value is the idea to prototype, and that's why we said it should be 100% funded by the government bodies. Then you have development, which is a major canyon, and that is also funded jointly. 30 to 40% by industry and about 50 to 60% by the government. And translation, by the time you have come to translation, which is a smaller revenue, that should be certainly assisted in a large way by the industry. That's the kind of funding pattern should be followed. This is shown in a similar form that you see the federal state funding in basic research 100%, translation research both of them, and by the time you go into translation, the industry takes up, the incubation centers come up, the regional innovation centers come up, and industry gets 100% into the financing mode at the end of the day when you are into the market. All of you have what is called technology transfer offices. The problem of technology transfer offices is that they have become administrative units. They have got just standard process, little recognition. All those who are not required are put in such centers because they are treated as some kind of, people who don't have much insight into either academics or in research or in their basic field. And these centers are risk averse. There is a gap between the two. University don't know compelling market requirement, lack of interest and resource for application development. Mostly individual small group of distributed research. Similarly, the industry does not know what the academia can give. So this gap can be done if you convert this technology transfer center into value creation centers, where this center will bridge this gap and also help in taking through that valley of death and also creating incubation. You should have a financial body, you should have entrepreneur management system, you should have people and scientists who can translate the idea from a particular size to a size which is acceptable to the market. So this value creation center, if it is done in universities as well as in the R&D organizations, will help certainly create this kind of a collaboration. Yesterday I gave this, and new engagement model I call it, because in the center is the R&D labs, which are today the 3 or 4 departments are already doing this, like the space, DRDO, atomic energy, and now it has started even in the biotechnology area, where you have large programs being done, where the concept, specifications, technology development is taken. Then you have a collaboration through this program in universities. Now universities have their ecosystem in which they have center of excellences, you have research parks, and you have regional institutions around universities who are forming the collaborative cluster. Similarly, on the industry side, which is developing the development and the product and the processes, they will set up the production targets, product upgrades, and lifetime support. And international collaboration, generally should be that all three should be involved, with R&D institutions taking the major role, so that the technology absorption and technology upgradation takes place in a much better manner. But what is needed is strong bond, adequate funding, facilitate easy migration of people from one institution to another institution, and establish common facilities so that there is enough infrastructure available without repeating it all over across for doing high-end testing and certification and qualification. This is very important. Basically, friends, I want to mention to you that we have all the ingredients and potential required for innovation. Let us convert this potential into reality by establishing a strong link between academia, industry, and national labs. I will go a step further, that if we do this, we can out-innovate the whole world. That's my suggestion, and I hope my panelists will be able to add more to what we think is a problem and how it can be solved. Thank you very much.